Okay, so again, good afternoon, class. Our last topic for the midterm is Thevenin's theorem, actually including this Norton theorem. So these are the last two topics for the midterm. This Thevenin's and Norton theorem are also useful tools, no, in solving complex circuits, just like your DC circuits. So gumamit din kayo ng Thevenin's and Norton's theorem para halimbawa i-solve yung current o kaya yung voltage, pati na siguro yung power dun sa parte ng circuit or network natin. So ganun din ang gagawin natin. So in the DC circuit, yung Thevenin's resistance ninyo is R sub TH, while in here, we call it C sub TH. Dahil nga meron siyang inductance and the same time meron siyang capacitance. Na? Tapos, yung open circuit tsaka short circuit, parehas lang doon sa DC circuit, BOC and ISC. So for the C sub TH natin, so we have R sub TH plus J sub TH. So our J sub TH equivalent to R sub TH and J XTH, the Thevenin's resistance and its corresponding inductive or positive resistance. So actually, it's represented by R sub TH plus J, no? Plus J, X sub TH. And sinasabi rin dito, yung C sub TH natin is also equal to our C sub N, just like in your DC circuit, your looking back resistance or Thevenin's resistance, R sub TH said to be equivalent to R sub N, Norton's equivalent resistance. So similar in here, since we're dealing with complex, so we have this complex impedance, say C sub TH is equivalent to C sub N, yung Norton's equivalent impedance. And at the same time, we have this conversion of equivalent circuit, say from Norton to Thevenin's or Thevenin's to Norton's. So in here, the left equivalent circuit is said to be Norton's, while on its right side, we have the corresponding Thevenin's equivalent circuit. Of course, in its equivalent circuit, meron silang open terminals, 2 terminals on each. So from these terminals, we can, of course, reconnect the element we are looking for. Let's say, for example, we're looking for the current in the 2 ohm resistor. So after we determine the Thevenin's or say Norton's equivalent circuit, then can connect that element across this open terminal for us to determine, say, the current kaya, voltage, or maybe power absorbed by that element. No? Okay. So, of course, we know that in a Norton's equivalent circuit, we have this what we call I sub SC, which is in parallel with our C sub N, whereas the Thevenin's equivalent circuit it has a series combination of voltage and this what we call Thevenin's impedance, B sub OC and C sub TH. Okay. From the open from the short from the Norton's theorem network, pwede nating kunin yung equivalent Thevenin's voltage VOC by simply multiplying this ISC to say sub n for us to determine this VOC in this Thevenin's equivalent circuit. And we mentioned here that Z sub n is the same as our Z sub TS. Conversely, we can also determine ISC from the Norton's, from the Thevenin's equivalent circuit by simply dividing our B sub OC to this Z sub TS. If we do that, then will give us this, what we call ISC of our Norton's equivalent circuit. And again, Zn is the same as our Z sub TH. So we can either use Norton's for us to determine the Thevenin's, or say Thevenin's to Norton. So we have this problem. So in this problem, we are asked to solve for the phasor current, capital I here, using Thevenin's theorem and verify using Norton's theorem. Okay, so there is a given situation here, sabi nga, the given problem is already in its phasor equivalent. As you can see in our given circuit here, no? They are already in phasor equivalent. Just like your impedance here, say 4 minus J2 ohms, isn't it? And at the same time, these two independent current sources are already in it is already in their phasor form. So hindi na natin kailangan i-convert yung say time domain to phasor equivalent since they are already in its phasor equivalent. Okay. Yun nga, sabi nga, so there's no need for us to convert from time domain to phasor. There's no need to transform the final answer from phasor to time domain since the problem only requires the phasor value of the current, capital I. Kasi as you can see here, we don't need to consider the time domain of the current I here because in our given problem, the required here is phasor current. You don't need to convert this phasor current into time domain. But if it is required, of course, you can do that. You can transform the phasor current I, say capital I here, to time domain. This is required. No? But in our problem here, it's not required. Okay. For the solution, as you can see here, try to consider first the say sub th. Of course, when we do that, we need to open these two current sources. So once we open these two current sources, we'll notice that these two impedances are in series with respect to the open terminal from this say sub th. No? So when we solve our say sub th, we remove this negative J10, right? We remove this negative J10, and from this terminal of our negative J10, we place our say sub th. Then after that, we remove all these current sources. We replace the current sources to open circuit. If we have, of course, a voltage source here, we need to replace those, say, voltage source or sources to short circuits. Just like what you did in your DC circuit, if you have a voltage source, then what you did there, you replace your voltage source to short circuit. So similarly here, we can do that. We'll also do that. If we have a voltage source, we're going to replace that voltage source to short circuit. But since there's no voltage source here, only current source, ay ang ginawa natin, we simply open our current source here. This 1 angle 0 and this 0.5 angle negative 90 degrees. So once we replace these two current sources to open circuit, the circuit will looks like this. The 4 minus J2, then be in series with our 2 plus J4. So from there, we can simply say that our looking back impedance, or say sub TH, is equal to 4 minus J2 plus 2 plus J4, or simply 4 plus 2 equal to 6, negative 2J plus 4J equal to positive J2. So meaning to say, our Thevenin's equivalent impedance, I mean, is 6 plus J2 ohms. Okay. So of course, our next target is to find the open circuit voltage, B sub OC, open circuit voltage. So to do that, we have to remove again our negative J10 since we're looking for the current here. So we have to remove this negative J10. Then after that, have to indicate our BOC from this open terminal. But when we determine our BOC here, we don't need to remove this current source, right? Only the negative J10, only the negative J10. And you notice then that once we remove the negative J10 and we replace it by this open terminal, and from there we place this BOC from this open terminal. So from this open terminal, we're going to solve for our BOC here, open circuit voltage. We notice with respect to these open terminals, the left current source here is in parallel with 4 minus J4. So similarly, the right current source also in parallel with this, say, 2 plus J4. For us to determine the voltage across the first combination here, kailangan natin i-multiply yung 1 angle 0 with this 4 minus J4. And at the same time, for us to determine the voltage across this, we have to multiply 2 plus J4 by 0.5 angle negative 90. And after that, maybe we can use KBL, say around this circuit following this clockwise direction here. So of course, if we start from this BOC following this direction, clockwise direction, we can simply say that our equation is positive BOC, then minus, because the direction of our current, right, our current source here is going downward. So following this direction, so we can simply say then the sign correspond is negative, say negative of 0.5 angle negative 90 times 2 plus J4. Then followed by the voltage drop across the second combination here. So again, the sign is negative since the direction of our loop here is clockwise. And if you try to consider the direction of the current with respect to the left current source here, you'll notice that our loop entered the negative terminal again of our left current source here. So if that is the case, the voltage sign then is negative. So negative 1 angle 0 times 4 minus J2 equal to 0. Then from there, we can transfer the two voltage drop, say yung voltage drop across the right combination and the voltage drop across the left combination. So in our solution here, our BOC is then, say, equal to 2 plus J4 positive times 0.5 angle negative 90 degrees, plus yung voltage drop across this 4 minus J2. The voltage drop is 4 minus J2 times 1 angle 0. So the corresponding sign then, after we transpose to the right side of our VOC, mapapansin natin lahat na ay positive. From negative going to positive when we transpose these two voltage drop. Okay? So combining now these two voltage drop, then we'll have 6.71 angle negative 26.57 degrees volts. So this now our open circuit voltage. So we know that Thevenin's equivalent circuit comprises of VOC and CTS, and these two elements are in series, of course. Then for us to determine the required current through the negative J10 reactance or impedance here, so we have to connect that negative J10 from the open terminals of our Thevenin's equivalent circuit. Actually, this is the open terminals of our equivalent circuit. So from this open terminal circuit, so we can simply connect, or we can now connect our negative J10 here. No? So again, try to consider this equivalent circuit. The direction of the current in our negative J10 is downward because of this polarity of our VOC. So we can simply say then the direction of our current through this negative J10 is downwards. So again, following KVL here or using Ohm's law, kaya our current I through this negative J10 is equal to this VOC over the sum of this combination, say TH and this load, negative J10 ohm. Yes. And after that, we can substitute the computed open circuit voltage VOC, and at the same time, the value of our CTH plus this one, negative J10. And our final answer is, or our current is 0.67 angle positive 26.56 degrees ampere. So that's how we determine our phasor current I in the negative J10 impedance or say reactance. Then after that, we'll consider the Norton's equivalent from the computed value of VOC and say sub TH from the computed value of our VOC and say TH. So we can simply say that our short circuit current I sub SC is equal to the ratio of that open circuit voltage and our Thevenin's equivalent resistance, say VOC over say sub TH. So substituting the value of our VOC, which is 6.71 angle negative 20.57, as well as our looking back impedance or say Thevenin's equivalent impedance, which is 6 plus J2 in here. So we can simply say that our short circuit current is positive 1.06 angle 45 degrees ampere. And we know that our Norton's equivalent circuit is a combination of these parallel elements, say I sub SC and say N or say sub TS. We already computed our say sub TS, so we can simply substitute that say sub TS in here. Actually, this is A sub N. No, which that say sub N is also equivalent to our say sub TH. Then after that, we can again connect the negative J10 impedance or reactance to the open terminal of our Norton's equivalent circuit. Since we already computed our ISC, we know already the value of our say sub TX, so we can simply use say current divider principle for us to determine this current I in our negative J10 reactance or say impedance. So the answer is the same, of course, 0.67 angle 26.56 degrees ampere. No? So that's how we determine our current I as using Thevenin's equivalent circuit as well as Norton's equivalent circuit. So after this, there are no other problem to be solved, kundi itong mga activity na lang So you have 4 activities here for the midterm. After this activity, final na yon. No? So ibig sabihin, nakafocus yung midterm natin dito sa mga theorem na to, yung nodal, mesh, superposition, Thevenins, and Nortons. Pagkatapos nun, pupunta na tayo sa power, final na yon. So ibig sabihin, ang gagawin na lang natin ngayon ay I'm going to give you the remaining activity, say activity 5, activity 6, activity 7, activity 8 maybe. Then after that, maybe I'll give you the second quiz para sa midterm coverage ninyo. So, tapos na tayo sa midterm natin actually. No? So, ang gagawin na lang natin yan, isesend ko na lang sa inyo yung activity 5. First activity sa midterm is this one. First activity for midterm is this one, problem number 1. Then the second activity for midterm, activity 6. Second activity, this one, problem number 2. Problem number 3 will serve as your third activity or number 7 activity. Maybe itong number 4 gagawin kong quiz or activity for sa midterm or activity 8. This one, this number 4 here. No? So kung gano'n, ginawa ko lahat activity to, bibigyan ko yun ng additional quiz. Bibigyan ko ng additional problem, magko-correspond sa quiz number 2 natin. Kung hindi naman, itong number 4, ito yung gagawin kong quiz number 2 ninyo. So next meeting, actually sinend ko na sa inyo yung first activity ninyo sa, ano ba to? Hindi. Sa canvas ninyo, sa canvas. Ito yung magsisilbing first activity nyo sa midterm, this problem number 1. This problem number 1 will serve also as your activity number 5. Kasi 4 yung activity natin sa prelim. So itong first problem nito will serve as your first activity midterm or number 5 activity natin. Na, tapos sa next meeting naman, ito yung magsisilbing second activity ninyo na pwede naman yung isubmit sa March 21, this problem number 2, then yung number 3, maybe March 28, tapos yung number 4, pwede kong gawing quiz ito. Na? Okay, so hintayin na lang ninyo sa canvas ninyo yung mga activity gagawin ninyo. So ang gagawin ko, iseset ko yung activity nyo, activity 5, siyempre ngayon, tapos yung due date nun will be on March 14. Tapos yung susunod na activity, due date March 21. Pero iseset ko yung initial date niya ngayon para yung gustong tumapos sa mga lahat ng activity, pwede nang gawin ngayon. Tapos lahat ng activity sa midterm, pwede nyo isend within this week. Yung may gusto lang. Pero iseset ko yung unang activity niya sa midterm, December 14, followed by March 14, followed by March 21, then maybe the last one na yung March 28. Tapos noon, yung last quiz ninyo sa midterm na to. Tapos, midterm exam na nun. So, siguro halos hindi na tayo mag-zoom yan. Mag-zoom class kasi tapos na tayo sa lesson natin sa midterm natin. So, siguro gawin na lang natin. Pwede kayong mag-request na mag-zoom tayo kung gusto ninyo. May GC naman tayo. You can ask me to open my Zoom class para sa mga susunod na activity. Kung wala naman nag-request, ibig sabihin, okay na sa inyo doon. Pwede na lang ninyo kung i-message siguro yung PM or GC natin. Na? So actually tapos na tayo. Ngayon kung may tanong lang, sige lang. Wala naman ano yan. Baka yung iba medyo nalito na sugot sa sinabi ko. May tatanong ba?
Ako po, sir, wala po.
Okay. So, medyo kahit magulo yung sinasabi ko, naiintindihan naman.
Intindihan naman.
Nagigits naman po, sir.
So, susunod, pwede na tayong hindi mag-meet, no? Kasi okay na tayo, tapos na tayo sa lahat. Kasi kung titingnan ninyo sa baba, nakalagay dito, finals na Tingnan ninyo, di ba? Lesson 6, finals na mag-a-advance ba tayo? Wag siguro, no?
Wag naman
po, sir.
Wag na tayo mag-advance kasi matatapos naman natin yan Kaya naman natin. Kaya wag lang natin mag-advance. Basta ang isipin lang natin, tapusin lang natin yung midterm to, tapos hintayin na lang natin yung midterm, midterm schedule. Na? Midterm exam. Ganun na lang. Tapos na tayo, isesend ko na lang kung kailan nyo ipapas, kung gusto nyo i-advance na ipas, walang problema. No?
Sige po.
Okay, salamat. Pwede na tayo siguro niyan. Na?
Sige po.
Okay, bye-bye.
Hi, sir. Good day po, sir.
Hey, sir.
Hey, sir.
Salamat, Johnny. Salamat,
Salamat po.
Johnny. Yes, Papa.
Johnny.
Eating sugar.
Ingat, bye-bye.